but not on mouse over yet. We have talked about that. That'd be really cool.
Well, can we get back to the thing, the VDJ part?
Yes. Yeah,
Because that's where we were
absolutely.
going, and that's what we're working hard on.
Right. So part of my issue with this is knowing kind of which population we want to pull clonotypes from,
Yeah.
and then what you want to do with those. So, we have some now memory and naive B cells defined.
Well, that would be good. Let's look at those. Memory versus naive. So what are those VDJs?
Right, that's
Would-
That would be
Could
fine.
we just, to make the comparison more robust, when we get to pie charts and such,
Okay.
is there how would you start looking at the plasma B cells here? Or are there any other subsets that we could pull out potentially?
Yeah. That's fine.
Is this? Yeah, sure. You can
One-
do.
CD1, CD38, or
CD38 positive, CD27 positive, that's possible.
yeah, that would be very interesting.
CD27 again?
Right.
Yes.
And then
Very.
Then how about
not
IgG?
too many.
How about
All right, IgHG1.
no, not one, but any of those.
All right, all of them.
All of these.
Right. I mean, there's IgM plasmablasts, but we're instant the IgG because that means they switched, and there might be more likely to be a pathogenic one.
You said all of these, including IgHG.
No, not that last one.
Yeah, just IgH 1, 2, 3, 4. I don't know what you. So let's,
So which of these is going to be labeled memory?
Right. Well, so let's change CD38 to CD27 instead.
Because that's the thing. Memory would also have some.
Right, it will have some.
so what do you? So it's the ones that are double positive.
Right, double
So
positive.
it's like I don't know which ones you think are good, but like draw data on the double positive ones there.
Right.
The ones that tend to be double. I mean, I know there's, or maybe, right, at least one heavy chain. That's okay.
Cool. Well, that gives us at least 3 things to compare against.
Oh, that'd be good.
Was it one? It was 38. That was another interesting marker.
Yeah, but there's not too many positive cells there.
And are we looking at 165 versus 166? Is that going to be part of this?
Oh yeah, could we compare 165 and 166?
We can. We haven't separated them out yet. It depends on exactly which cells we want to compare within those 2 samples.
All right.
Probably well, the same. Probably players just for
Let
heck.
Ian do this
Okay,
first
okay.
then. Yeah.
We're just looking at these subpopulations would be
Right.
good. The plasma, any like plasmablasts, they would be good. They'd be very good
Right.
because they're probably producing potentially antibodies, autoantibodies in the
So
sick.
now that we've got a few populations defined, I'm going to just save this workspace because I may want to go back to this after our talk.
Right.
Right.
And if you could send the workspace to us too.
Sure, of course.
Start where you leave off here.
Put that finish, okay. And then I want to jump into VDJ now that we have some populations to compare. So I'm going to go ahead and run just off of this B cell, what we think are B cells population. Workspace plugins. And here's the 2 pieces of meta information for those 2 samples.
Oh, so it gets a little bit of both. They're both mixed in there.
Yeah, they're both in there. We did not do any exclusion based on the samples, so we
Oh.
should get examples from both.
Oh, that's good.
Yeah. And then I threw, so these are the three that you kind of identified for me. I also threw in these extra two populations. I figured no harm in looking at those as well. And then we could look at a variety of different pieces of information for these. So, for example, here's the variable gene diversity among the different populations. You do have to kind of scroll this to the side to see which populations you're looking at. And you can change these colors on the fly. I'm probably fine with these ones, but you can adjust those. And then if you want to keep this image, you can save it to the layout,
Yeah, good
or
idea.
you can keep it to file as well. So this is back in the layout editor. Whatever image you're looking at in the BDJ Explorer is what's going to be saved back to the layout editor. So, you know, careful that you show your legend, for example, if you want that.
So
There's some
the,
big,
I'm sorry, the plasma cells in the two populated 165 and 166, is there a way to show which ones are 165 and 166?
yes, but it's probably not going to be a job for the BDJ Explorer. It's doable back in the workspace. So right now, currently we're looking at all of the rows from the meta information that were mapped to the plasma B cell subpopulation. And if I select this and hit Control All, I can select all of those different rows and create a population. I'm going to want to make me name that uniquely, so I'll call this plasma B cell clones. And that should create a population back here, plasma B cell clones. So it looks like I isolated 40 different cells for which clonotypes were mapped. But you guys may have some a priori knowledge about the type of clones that you want to look for within plasma B cells. And in that case, we could filter on any of these pieces of information. I just don't know what to search for with regard to that, cell type that would be of interest to you guys.
We were just looking at some data, with Loop, because Loop has a software. You know about Loop. The Loop the Loop.
Oh, yes. Yeah. They have a VDJ browser, I think, right?
Right. And what we noticed, interestingly, was, of course, it's 5' sequencing, so it did not have a lot of, sometimes the D regions were a little hazy. I mean, I think they were valid. But the other thing that was interesting is there was a lot of ones that had a kappa or heavy and a light chain, but not both, and sometimes not either. Maybe it just confined them when it's sequenced. But what might be interesting is like the ones that have both. See, I noticed a kappa, but then a heavy chain. And what would be interesting is make sure the cell had both, because those are the only cells we can use when you make the
And I think it does do some filtering on that for like top clonotypes, because it needs both in order to identify a particular clonotype.
Oh, really?
Yeah, so like you can actually look back at this clonotype list, and it gives you the amino acid sequences for both the heavy and kappa chains associated with any given clonotype that was called. So this should be one cell with a particular clonotype, for example.
So there's an IGH is. Can you do that again? The top clonotype.
Sure. Well, this isn't the top clonotype. This is just a list of the clonotypes in this B cell subpop that we mapped.
Oh, I see. So it gives you the heavy and the light and the diversity region, and the J, it's calling that, and the constant
Right.
region.
And if we wanted to create subpopulations out of this kind of information, we would use this. Currently what we have is this top clonotypes option. And if I right click here, I can choose the number of top clonotypes. Now, I think in your data, it's all like each clonotype is represented by a single cell. So you don't have like multiples of any of these, but you can do like the top 20 clonotypes. If I click create, it'll take a little while